Hi, this is Leslie Langno, Managing Editor at Design World Magazine, and today I am here with Nick LeCarry at Fisher Unitech, and we are here at SSOE where they are hosting the 3D RV vehicle event. So Nick, first of all, why are you here at this event?
We are here to promote 3D technologies of all sorts to different companies. You know, our policy is really Destination 3D. It's for everyone, and it really is. Everyone out there can use it in some respect, whether it's hardware or software.
Okay. And you have some interesting parts here that you brought to show. This one in particular, can you kind of talk about this one a little bit?
This is a tool made out of our Alta material, which is to hold other tools in a CNC. So this part comes out, we're able to clip the customer's components inside, put it back in, and mount it into the CNC.
And this would be a fixture that they could design and develop and use for any of their parts in a manufacturing application.
Absolutely. It's just a nice, cheaper alternative to actually using their CNC to then create this. So they're saving money and machine time as well.
And another thing I noticed was this little piece here. Can you tell me a little bit about that?
You know, with the multi-jet modeling, we're getting a lot into the injection molding and also blow molding with the smooth surfaces. So we're able to do very short run injection molds, get some parts out real quick, using the actual materials that the customer desires instead of, representations off of the technologies that are available.
Now, how comparable is this to an injection molded mold?
Accuracy-wise, it's good. It just can't handle the heat and the pressure. So again, short runs, changing your cool down times between cycles, that sort of thing. But the material's the same because it's what they're blowing in anyways.
Okay. And then how about this piece here? This has got metal as well as...
Well, this was a tool, if a customer needs this shape created out of sheet metal, they would typically mill this out of metal and then hydroform around it. So now we're able to make the tool off of one of the printers, and then they can hydroform around that. And again, just time and material savings. That part's probably 20% what it would cost for them to machine it.
Okay. And you have another part here. Tell me a little about this one, because this is a little unique.
Yep, this is an FDM part that we actually paused during the build and inserted a nut inside. So now we have true metal threads, so we're able to, get the functionality we would out of our part.
Now tell me a little bit about the pausing, because I think that's something that engineers are curious about as to exactly what part in the program do you stop it in order to put in an additional part.
Well, in this particular model, we used the Insight software, and we told it which layer to stop building. We deleted the supports through that software and basically used that nut inside as the support structure.
Did you add the nut inside in the middle of the build and then continue to build around it, or did that come at a later time?
Nope, we added it right in the middle of the build. So
wow.
The machine, as far as it's concerned, didn't know it was there.
Wow. So what are some of the more interesting things you've seen developed with 3D printing?
The stuff that really intrigues me is when we do a lot of the like replacement limbs for people that have been injured, that sort of thing, or any sort of medical application that it's helping somebody where normally it would be very expensive for them to do it otherwise, so they couldn't afford to get what they need.
All right. Well, great. Thank you so much for speaking with me today.
Thank you.